Hello friends, I am Sanjay Gupta. In this tutorial, I am going to discuss about dynamic memory allocation. So first of all, let us understand about memory allocation. There are two types of memory allocation. First one is static memory allocation. This memory allocation takes place at compilation time and we cannot increase or decrease size of allocated memory at runtime. It means if we want to increase the size of memory so that we can store more number of values, so it is not possible in case of static memory allocation. To avoid this problem, we have another memory allocation which is known as dynamic memory allocation. This memory allocation takes place at runtime. In this memory allocation, user provides the required size of memory at runtime. So in this memory allocation, the wastage of memory is less as compared to static memory allocation. There are some examples of static memory allocation. First example is integer variable, which is A, second float variable B, third character variable C, fourth integer array D, fifth float array E, then character array F. So in all cases we cannot change size of variables at runtime. So first three are normal variables which can store only one values at runtime, and remaining three are arrays which can only store maximum 10 elements which are entered by the user at runtime. So if we want to increase or decrease these size, we can use dynamic memory allocation. So this is the some predefined functions which are used for dynamic memory allocation. So there are total 4 functions available. First function is malloc. Malloc allocates memory at runtime and initializes each block with garbage value. Similar to malloc, there is another function which is known as calloc. So calloc allocates memory at runtime and initializes each block with 0 value. So both malloc and calloc allocates memory at runtime, but one initializes all the blocks with garbage value and another one initializes each block with 0 value. Third function is free. This function deallocates dynamically allocated memory. And last one is realloc. Realloc reallocates already allocated memory. Suppose we have allocated some memory with the help of malloc or calloc, and now if we want to modify the allocated memory, then we can use a function which is known as realloc. Let us understand dynamic memory allocation with the help of an example. So dynamic memory allocation cannot implement without the help of pointer. So pointer is the most important feature through which we can perform dynamic memory allocation. Then using this printf scanf, we are asking size of the array from the user. So the size which will be provided by the user is stored inside n. Now this p is a pointer which will receive the address of dynamically allocated memory. For this purpose we are using malloc. This size of int will provide size of integer data type, which is 2. This 2 is multiplied by n. So it means suppose n is 5 and size of int is 2. So total number of bytes which will be allocated is 10. So malloc will allocate 10 bytes. Using this int asterisk, those 10 bytes will be converted into integer pointer and the base address will be assigned inside the pointer p. Now if we want to read or we want to process this array with the help of p pointer, then we can see the first loop. This loop contains a scanf statement, and inside scanf we are using the expression p plus I. So p contains base address of the array, and if we add value of I, which is 0, 1, 2 and so on inside this pointer, so every time the base address will increase by 2 bytes, and whatever value will be provided by the user will store inside a particular address provided by the p plus I. Now if we want to process this array using p pointer, then we can use this loop which contains a statement s equals to s plus asterisk p plus I. So p plus I will provide address and if we apply asterisk on p plus I, so it will dereference that address so that the value which are stored inside that address will gets add in s variable. So after completion of this loop, the printf statement will print the value of s on console, which is sum of the numbers entered by the user. After completion of all the processes, we can free the pointer p so that dynamically allocated memory can be used by the another program. So now you can easily understand the difference between static and dynamic memory. In static memory, programmer will decide the size of memory, and according to the programmer's size, user have to enter the required elements. But in case of dynamic memory allocation, user will decide the size of memory and user will enter the elements according to the provided size. So dynamic memory allocation is far better than static memory allocation. And also remember, this can be achieved. This means dynamic memory allocation can be achieved with the help of pointers. Thank you.